mull it over. Our computers are having issues, so I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, she says, the mildly flustered shopkeeper at the North Pole Toboggan Rental Shop. Oh, that's cute. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? Oh, this is getting too real. The computers appear to be trying to run a program, but its memory, your puzzle input, is corrupted. Oh, how fun. All the instructions have jumbled up. Ooh, okay, instructions. It seems like the goal of the program is to just multiply some numbers. It does that with instructions like mul xy. Oh boy, oh man, okay. Where x and y are each 1 to 3 digit numbers. 1 to 3 digit numbers. Okay, like 0 to 999. For instance, mul 44.40 or mul comma 44 46, whatever, I said it wrong. Multiplies 44 by 46 to get a result of 2024. Oh, that's cute. It's the year. Similarly, I can talk today. Mul 123 4 would multiply 123 by 4. Okay, yeah, this seems very straightforward. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of mul instructions. Sequences like mul 4 times, comma mul 6 9 exclamation mark or question mark or mul 2 4 do nothing. Do nothing. Okay, interesting. Oh, so spaces are even considered invalid too. Interesting. For example, considering the following section of corrupted memory. Oh, I see. Okay, cool. I like the highlighting here, where I can just... Oh my... My brain automatically jumps to solutions, and my brain's just like, yo, regex. Like regex. Like regex. But let's keep going. All right. Yep. So it needs to be mul. It needs to be an open parenthesis. It needs to be a 1 to 3 digit number. Oh, yeah. Only the 4 highlight sections are real mul instructions. Adding up the result of each instruction produces 161. Okay. Scan the corrupted memory for uncorrupted mul instructions. What do you get if you add up all of the results of the multiplications? Okay. Okay. This is cool. I like this. Make dir day 03. Go into that dir. And now we can vim example input.text. So this is the example input that they gave us. And here, I'll show that. And they showed me that the instructions, when you do all the multiplication and then get the sum of them, we will result in 161. So as long as we can turn the valid mul instructions into 161, we are good. So let's make our first program, I guess. What should the name of this program be? Let's just call it multiplier. Sure, I don't know. User bin env bash. Quit out, come back in, we get our nice syntax highlighting. I'm sure there's an easier way to do that, but that's just so muscle memory to me, because it also writes out the file. I like that. So we are doing day 3's puzzle here, and I just grabbed this example input. So now in my terminal here, we can see we have example input. This is what they gave us on the website. We have our program called multiplier, and we have real input.txt. If we do a word count of characters on real input.txt, there's 18,000 characters in that. By contrast, for the example input, there's 72. So my program better work. Let's open up the multiplier program. Actually, let me look back at the example input. I really think regex is the answer here. Like, I think this is actually going to be very simple. We just need mul, open paren, a 3-digit number, close paren. And I think we just do this, like, forever. Let's chmod plus x multiplier. And let's try and do a regex for this. So if we did a regex equals, we're going to look for mul, open parenthesis, which I think I need to escape. And then in here, I'm going to do a parenthesis, 0 through 9, and we want that 1 to 3 times, comma, nope, close parenthesis, comma, open parenthesis, open square bracket, 0 through 9. Sorry, anybody watching this who isn't familiar with regex. I don't know if I can explain all this. I'll try, but I'm fairly comfortable with regex, so this is convenient that this is what we have to do. I think this is good enough. And what this regex does is we're going to match for the literal M, the literal U, the literal L, and then the literal parenthesis. And then this parenthesis is special to regex. This parenthesis puts these in a group. So whatever's inside the parenthesis gets put in a group. So here's what's inside the parenthesis. And what's inside, or parenthesis, I think parenthesis is plural. Someone corrected me on one of my comments. on my socials. I think it was Instagram or TikTok. I don't remember. And I think I've been saying it wrong. I think I say parenthesis when I mean parenthesis. I could be wrong on that, but I should double check that. But yeah, so we have 0 through 9, and this should appear 1 up to 3 times. So at least 1, at most 3. And then we do the exact same check here, and then we close the parenthesis. Or we close the parentheses, because we're putting a parenthesis to close the parentheses. I'd have to... I'll worry about that later. So if we have this regex, then we can do a regex match on this. So let's try this. We should read the entire input as one big string, right? Is the entire input just one line? I think it is, right? Example input is 1 line. Real input is 6 lines. Should there be 6 lines? I guess new lines will just be random characters from it. So we need to read the entire thing. So what we could do... let's just do the entire string here. We'll just read the entire thing, dev standard in. And that should just read the entire thing as a string. Let's just double check that this works. If we do multiplier on the example input, then we get that. Nice. If we do it on the real input, then we get that whole big thing. Hey, that works. That's awesome. So let's go. Let's take a look and let's see what we can do here. I have to remember how to do this in Bash. Like, can I get all of the matches? Can I keep going through the input and the output? I don't remember. So this will be fun. How do we do regex matching in Bash? I think you do this. If $s is it this syntax? Also, just a quick message for the chat. I will sometimes hide chat when I'm figuring this out, and I don't want someone to hand feed me the solutions. If you guys want to throw out ideas, hey, that's totally cool, but I don't want any like backseat, gaming style thing. But I'm cool if you guys want to chill out or throw out like, hey, maybe this will work. Like, that's cool. But yeah. So I'm okay getting the syntax wrong and then iterating and getting the syntax right. Like, I'm okay with that. Let's put this in an ifs just to make sure. Echo. Let's just echo the whole array. Bash rematch. Rematch is for regex match. This will have every element of the match of the regex. In fact, let's separate them by new lines. Okay, let's run this on the example input. Cool, so I got that syntax wrong. Maybe it's this, or maybe it's just the tilde. Okay, hey, that looks really good. So they actually got the first one out of it. That's great, mul 2 and 4. So now we need to check again for, we need to keep going. I actually don't know how you do that with Bash. Is there a way you can do that with Bash? There's gotta be. Yeah, I'm pulling up the Bash man page and I'm just gonna look for rematch. There must be something here. You have to just like, I'm trying to remember if there's a way to keep checking the string for continual matches, or if I need to like filter this out of the string and then try again, or loop over it character by character. This is an interesting problem. I know how to write these regex, but I don't know how to check them very well. I could cheat. I could definitely cheat. And what I mean by cheat is I could take every single closed parenthesis and replace it with a closing parenthesis and a new line. And then I could just do the whole thing line by line. So let me explain what I mean when I say that. So let's echo S here, and then let's just throw an exit here, so we're not even going to touch that code. It's as if I commented that code out. And we have this. Okay, so now I can do a nice find and replace on this variable. And we can say find every closing parenthesis and replace it with a closing parenthesis new line. Is that valid syntax? Can I just do a new line like that? I might have to do something a little bit different. Nope, I'm replacing it with a literal N when I do that. There is a syntax for this. Is it this? Okay, that worked. So that's very confusing syntax. This is find and replace. The 2 slashes means we're going to find every single occurrence of this closing parenthesis. I'm just going to say parenthesis until I learn what it is. And we're going to replace it with the parenthesis and a new line character. That's what we're going to do. So now, if they were valid, they still should be valid. Now we just have to go through and match on a line-by-line basis. So we can do this. Let's save it. We'll overwrite it. And then we'll do... what's the best way to read it in? Probably with a while loop. While read -r line, do, done. And we're going to read in from a here string of s. And then we're going to do a nice little regex match on that line. And let's just say if it doesn't match, we'll continue. We'll do the next iteration of the loop. So now this should find every occurrence of that. Well, it found 2 and 4 a whole bunch of times, so I'll have to switch something. Okay, so we have this regex, and we're going to do it line by line. We're going to match on the regex. If we don't match, we just continue, which goes through the loop again. We're looping line by line, and we're going to print what we've matched on. So when we run the multiplier with the example input, we can see that, hey, that's wrong. That's not even close to right. We should not have 2, 4 all the time. So what's happening here? Well, let's look at S here. Oh, okay. I already see the problem. I define the variable here as line. Yep, line, and I'm calling $S here. So that would have never worked. I'm just matching on the whole input every single time. So that was just a stupid user error. Stupid error by the user. Not that I'm stupid, but that's a different story. Hey, look at that. That looks beautiful. We are extracting the multiplication instructions just fine. According to the website, the Advent of Code page, we should be able to extract 4 from this, and it should be 2, 4, 5, 5, 11, 8, and 8, 5. So we got it. We're good. And now the beautiful thing is this bash rematch is our matches. It's an indexed array, and the first element, the element 0, is the entire thing that matched, and then we have the 2 things that we had in groupings. This is no different than any sort of matching with regex in other languages that you may or may not be used to. So what can we do with this? We can save the variables as like, I don't know, left-hand side, bash rematch, short for regex match. Right-hand side, this will be 2. Let's not print these anymore. And then we need to multiply these. So product equals left-hand side times right-hand side. And let's go ahead and echo that product. This is just for our own sake. 8, 25, 88, and 44. I don't see those actually anywhere on the example. So I'll just try to see if I can get the answer from the example, which Advent of Code website says is 161. So as long as these add up to 161. So we'll need an accumulator. And then we will just accum plus equal... oh, wait. It's bash. Accum plus equal product. We have to do it in that notation so it knows it's math. Echo total is accum. This will be the total of all the products of all the multiplication instructions. And we get 161. That is what we were supposed to get. According to the website, I'll pull it up for you all here. We can see that 161 is what we were supposed to get. So that is amazing. We might already be done with part 1. So let's go over here and run it on the real input. And we get a total of this large number. I'm scared. That number seems like it might be too large. It could be correct. It's probably correct, but it seems very large. I'm a little scared. Let's go over here, put the answer in here, and submit. That's the right answer. You got 1 gold star. Let's go. All right, day 3, part 1 done. In fact, I realize I haven't actually had a bad submission yet, which is really cool. So I don't even know what that screen looks like. I kind of want to fabricate one just to see what that screen was, or maybe I'll just hit it naturally in the future. But what I really like about this challenge, and actually Eric talked about it in the behind the scenes video, is that there is no penalty for wrong answers. And I'm assuming the website does the same thing, but like I have example input and I know what the example output should look like. So I can just sit here and reiterate until I know it's perfect. That is such an empowering thing when it comes to being able to educate yourself and learn how to do this. So yeah, I'm super excited for that. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. Okay. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. Neat. There are 2 new instructions you'll need to handle. The do instruction enables future, oh boy, enables future mul instructions. The don't instruction, the instruction has an apostrophe in it. That's beautiful. Disables future mul instructions. Only the most recent do or don't instruction applies. At the beginning of the program, mul instructions are enabled. Okay. This seems okay so far. So basically we have this like do and don't, and all they will do is toggle a flag on if it's enabled or not, and it will start in the state of being enabled. Okay, this all seems straightforward. The corrupted memory is similar to the example from before, but this time the mul 5 and mul 11.8 instructions are disabled because there is a don't instruction before them. The other mul instructions function normally, including the one at the end that gets re-enabled by a do. This time, the sum of the results is 48. Okay, that makes perfect sense. Handle new instructions. What do you get if you add up all of the results of the just enabled multiplications? Okay. Okay, cool. What I'm noticing here, though, is I think is the example input here different than what I had on part 1? I think this example is slightly different, right? Can I just scroll up to see part 1? I can, yeah, because this one has do underbar not, and then it has a then, whereas this one is slightly different. Okay, so I'll save this one as example2.txt. Let's do example input 2.txt. We'll save this. This is directly from the site. So now if we cat that out, you can see that's what it looks like. That makes sense. And when we get the sum of this, we should get 48. Cool. So let's go ahead and CP multiplier with, let's just call it multiplier part 2. Multiplier part 2. Okay. So we have the mul instructions that we want. We're going to want a do and a don't instruction. This is so wild. Okay. Let's think about how we're going to do this. Because right now what we've done is we've taken every parenthesis. I actually think the way we solve this is going to be useful because we took the closing parenthesis and we added a new line to it. So let's go ahead and just cancel these out. Don't even care what this accumulator is. Don't print the total. Let's just echo this line and see what we get. So we're going to parse it line by line, and that's all we're going to do is we're going to print out what line we've seen. But we've added our own line break, so we're going to get more than the example input has. Of course, the example input has 0 line. Well, 1 line because there's only one. It's only 1 line long. So we have the mul instruction. We have the don't. We have the mul that's been turned off. We have the mul that's been turned off. We have the do, which is so funny that it's undo. And then we have the mul that's turned on. Oh, I think this is going to be more than doable. That's crazy. Let me think about this. I can actually tighten up my regex now that I think about it. Because we've put the closing parenthesis at the end of the line, we could actually anchor this here. I think we can do that. We have mul. Let's do mul regex, do regex, and don't regex. We'll just make 3 variables, and I'll think through these as I'm writing them. But I think this is going to work. Famous last words. Do. End of line. And then we have don't. That's going to be a problem because of the quoting. The quoting is going to be an issue, but that's okay. And then don't, open and close, paren, end of line. But we'll have to put a backslash to escape it. But because we're using double quotes in bash, we're going to have to do a double backslash to escape the backslash. So regex will process one. Bash will process 2 slashes, which will get turned into 1, and then regex will process 1, which is exactly what we want. Oh, that's a fun little trip up with that apostrophe in there. Oh man, if I wasn't so comfortable with the syntax, that would have been annoying. All right, so enabled equals true. We start in the enabled state. So let's do this. If line equals do regex, then enabled equals true. elif line equals don't regex, then enabled equals false. Elif line equal mul regex, then if line equals mul regex and enabled. So if it's enabled and we match the multiplier regex, then we do this. And I think that's it. Let me look over this logic real quick before I do it. So we have the enabled flag start to true. We have the accumulator set to 0. We check if it matches the do regex, then we enable the flag. Then we check if it matches the don't regex, because we only have to process one per line. There will only ever be one instruction on one line. And then if it equals the multiplier regex and it's enabled, then we actually do the work. So if we do this, oh boy. Multiplier part 2, example input 2. Let me look at the website. The website says the sum of the results is 48. It doesn't take an argument. It reads from standard in. Total is 48. I think we're good. Using all the tools you have, modify the data in a slightly different way to get a slightly different answer. Like, I think it's really cool. Wow, look at that total. Okay, this is meaningless. And each puzzle input is unique to the user, so even the creator looking at this has no idea if it's right or wrong. We're just going to have to let the website tell us if it's right or wrong, which is really, really neat. So let's go ahead and submit this. That's right. You're 1 gold star closer to finding the chief historian. You've completed day 3. You can share this victory or return to your advent calendar. We did it. Day 3 down. That was awesome. That was a super fun one. Oh, man. Nice puzzle. I really like that one. That was super interesting.